So hello guys, welcome to my YouTube channel Data Stories. In the last lecture, we have studied about what is meant by supervised learning, unsupervised learning, and steps involved in model building. Till step 3, we have covered the practical. So in this video, we will see the supervised learning. What are the algorithms are there in supervised learning? So basically, and yes, if you haven't watched my previous videos, please watch it as you will get the concept that I have explained here. Okay, so let's proceed. So basically supervised learning is classified into two categories. Okay, we can say regression classification, regression, and okay, first one regression, and second one is classification. Okay, and one important thing, whatever whatever thing I'm writing down here, you should have a pen and copy with you, and you should copy all the things that I have written here, as it will be very useful for you at the last moment to revise. So please have a pen and copy with you. So supervised learning is classified into two categories like regression and classification. In the regression, the output is real and continuous value. Uh, okay, I will write it down and then I will explain. First one, regression. Regression, right? In regression, the output is real and continuous. For example, we can say weight and height, or house price prediction, right? So regression is that in regression, the output is real and continuous. For example, weight and height. Okay, just tell me that your weight and height is constant or it is continuously changing. It is changing, right? After a particular time, it is changing and it is not fixed, right? Like your weight is right now before eating 40 kg, and after eating, it will be like 42 kg. So it is not fixed. And in house price prediction, in house price, okay, we are predicting the house price. The house price changes every day. Like today, the price of the house will be like 50 lakhs, and after 2 years, it will be like 1 crore. Like it is not fixed. It may be reduced or it may be like gain. So this is regression. Like the values are not fixed. They are changes continuously. Okay, I hope you understand the concept. And second one is classification. In classification, variable is categories. You may understand by reading this sentence. Categories, for example, you can say gender, male, female, yes, no, type questions, yes, no type output. These are classification, right? Okay. So we have seen supervised learning. It is classified into two types, regression and classification. I've explained regression and classification. Okay. Now we will proceed to the next topic, that is linear regression. Okay. So what is the equation of linear regression? Equation of linear regression is equation of linear regression. Y equal to b naught b naught plus b1 x1 plus oops plus b2 x2 plus L bn xn. Okay, so in this b naught is intercept, y is dependent variable, b1 b2 is b1 b2, b1 b2 are the coefficient for the independent variable, and x1 x2 are the values for the independent variable x1 x2. Okay, so please note it what I have just said. So in linear regression there are some evaluation parameters that we will see. Evaluation parameter in linear regression. First one is MSE, mean square error. Second one is RMSE, root mean square error. Third one is R square. Fourth one is adjusted R square. And fifth one is mean absolute percentage error. Okay, so we will see this in detail one by one. So first of all, starting with R square. Okay, first we will start with R square. R square. What is the range of R square? Range 0 to 1. Okay, R square, like R, it has square, so it allow only positive number. It allow only positive number. And last one is that I will write it here. These are the most important point. Higher the R square, better is your model. This is the most important step, so I have write it here. Please remember it. Okay, so second one I will take adjusted R square. Adjusted R square. Okay, why we are taking adjusted R square? Because in R square we are considering the insignificant columns that are not useful in prediction. So we are using adjusted R square here. R square will contain both significant and insignificant column. We don't need insignificant column for the prediction. So we are considering adjusted R square as our evaluation parameter, as it doesn't contain insignificant columns. Okay. So what is the formula of R adjusted R square? So R square equal to 1 minus 1 minus 1 minus R square into n minus 1 divided by n minus k minus 1. Okay, so n is number of record, means n is number of rows, k is number of x variable. Okay, and you can you tell me that adjusted r square can be greater than r square? Uh, I hope please write me a comment that adjusted r square can be greater than r square, and then I will tell you the answer. I hope you have commented. Now I will tell you the solution. Adjusted r square can never be greater than r square. Why? Why did so? Because in r square we are considering both significant and insignificant variables. So the amount will be huge. And here we are considering only a significant variable. So it can never be greater than r square. Okay. So higher the adjusted r square, better is the model. So this is the most important step. I will write it here. Higher the r square, adjusted r square, better is your model. Okay. So in this video, we have covered the two evaluation parameter. In the next video, we will see the next evaluation parameter of linear regression. Okay. So I hope you are revising the concept, and if you haven't subscribed to my channel, please subscribe it and also like it, and it will give me the motivation to bring more videos. So thank you for watching my video. I will see you next time.